Thank you. I must thank the organizers for having this panel on adapting machine learning strategies, to the COVID era. I have to thank my panelists. We have Darko, we have Yevgeny. We are waiting for Edward Mitby, who should be joining us soon. I'm really looking forward to this panel, especially because I have immense regard for all of you. And each one of you is pushing the boundaries of AI in some very interesting ways. And I look forward to a very exciting session where I get to learn from you all. Right? So thank you, Darko, and thank you, Yevgeny. So maybe we start by briefly introducing ourselves. Maybe you could talk a little bit about your background and your current work. Darko, can we start with you?
Absolutely, yes. Hi, everybody. So exciting to be here. And thank you for the introduction. So just a very brief background on myself. I have a PhD in machine learning. We didn't call it AI back then, but now it's all a buzzword. It's great, very exciting. And I then spent a bunch of years working at top research institutions like the National Physical Laboratory and bunch of hedge funds like Man Group. But let me tell you about what we are currently doing, because I think it's definitely the way, the most exciting thing yet for me. So I'm the CEO of CausaLens, and at CausaLens we're bringing a new type of intelligent machines to market. We broadly call this causal AI. And the implications for our field are huge, right? Despite the buzzword of AI, we really just have curve-fitting machines today. Essentially machines that can fit curves or hyperplanes to data. And that's all we have. And if you don't really understand the maths behind it, it may look like magic and wonderful, but really that's all it boils down to. So our mission is to improve matters and go beyond curve-fitting machines. We want machines to be able to understand cause and effect, and the financial industry has been, has adopted our technology at large, and we've had some really exciting successes. So that's a brief intro on us.
Thank you, Darko. Yevgeny, could you please introduce yourself to the audience? Thank you.
Sure, Rajesh. So my name is Yevgeniy Vahlis. I lead the AI group at the Bank of Montreal. I've been at this company for about two and a half years now, and we've scaled up the AI team there from the ground up, essentially. We recently launched a couple of products which you may have heard about. One is called Cash Track. Cash Track uses deep learning to alert customers of a potential shortfall, avoid overdraft fees, and so that product won three different industry awards. It got a lot more traction than we originally anticipated, so that was great. It's great to see a deep learning technology having that type of consumer impact. Prior to BMO, I built the applied AI group at Borealis AI, which is the Royal Bank of Canada's Artificial Intelligence Institute. And prior to that, I worked at venture capital, Amazon for some time, and a bunch of startups. And my training is a theoretical computer scientist back in the days, but that was a long time ago. And excited to be here.
Thank you, Yevgeny. I did see the press release from BMO, and I saw the social media posts on the two awards. So congratulations on that.
Thank you. Yeah.
And then we come to you, Ed. Thank you for joining us. Could you please give us a brief background and some introduction?
Yeah, thank you so much for having me. So I'm a senior AI engineer at Vanguard. My background is in optimization, simulation, that type of thing. I really got into, I was in theory doing machine learning type stuff before machine learning was cool many years ago, before GPUs came along and that type of thing. So I'm very excited about what's going on in the world. So there's a lot of things happening. It's happening very quickly. At Vanguard, I've got a pretty unique opportunity to try a bunch of different things. The vast majority of my stuff is obviously on the structured data side. You know, not so much AI in theory, right? Vanguard doesn't need a lot of computer vision. But, you know, there is a lot of room for like NLP, you know, regex type stuff, you know, searching through documents and that type of thing. But the vast majority of stuff I do is actually technically machine learning, meaning XGBoost, random forest, that type of thing. We have a lot of different initiatives. I've been given a directive to keep this as vague as possible because I'm not supposed to let anyone know what we're working on. But yeah, we've got a lot going on. And I'm excited to be here, and thank you so much for having me.
Perfect, thank you. Thanks to all three of you to join. And in some sense, in the intro I mentioned, all three of you are pushing the boundaries of machine learning AI in three different directions. And this is what I want to explore with you in a little bit more detail. So we'll start with you, Darko. When I think of traditional quants, right? I in the audience is very familiar with very classical ideas of causality, right? This is your standard Granger causality or your Engel-Granger test or co-integration, right? And so what are the limitations of what we think of causality right now? And how should we think about your approach? How do we bring in causality into machine learning?
Yeah, absolutely. So actually econometrics and in the field of econometric causality was the first implementation was in econometrics, and that was actually very visionary. Granger in 1969 actually proposed this method. It was truly unique. You know, no other field had even contemplated the notion of causality. Everyone else was doing associations or correlations, and Granger comes out and says, "Look, guys, we need to do better than correlations." And so that was really visionary. Now, for 1969, that method was wonderful, but unfortunately or fortunately, we have now more powerful ways to do this. So when people think of causality, they think it's like a separate discipline. They find it hard to think of causality within machine learning. But I think if we are just thinking, oh, it's either econometrics or it's just machine learning, we are actually missing kind of the best of both worlds. Now, let me just take a quick step back and explain why causality is so important through an example. So current machine learning methods, all they can do is they can pick up associations in the data, or in other words, correlations. So let's look at shark attacks and ice cream sales. If I have a data set of ice cream sales and I have shark attacks, what my machine learning model will learn is that ice creams sales cause shark attacks because they both go up in the summer. The hidden confounder or the causal driver is the summer, not the ice cream sales. If I have a solar panel and if I measure the sun exposure, but all sorts of other irrelevant variables, my machine learning will learn that all the irrelevant variables actually cause I don't know, the power output of the solar panel to go up, but really it's just the sun. It's just one variable that matters. And when we do this in finance, this problem is even harder because we have infinite number of variables that are associated with the target, and we have low signal to noise ratio, which means that correlations are always low, or they may be high but spurious. So it's super important for any financial application, especially in time series domain, that we understand the difference between things that are correlated and things that are causing each other. So that's just why causality is important. But these all traditional methods like Granger causality have a lot of limitations. One of them being is that they assume that all of the data that is relevant is in the data set. Now, this is formally known as causal sufficiency. So they assume there's a causal sufficiency. In finance, unfortunately, that is never the case. So that's one problem. The second problem is that they assume stationary time series data. And that is clearly not the case. Financial time series is anything but stationary. So that's the second problem. And the third problem is they assume a linear relationship in the data. And that is obviously also a problem because most of the most interesting things are non-linear. So those three problems, you know, are there. We've taken those three problems, invented new methods that do not have those assumptions, and we've managed to put causality, you know, in a very, you know, machine learning, cutting edge machine learning sense, so that we can learn from the data, and we don't have, so we don't get these spurious correlations, and we don't have these limitations of existing methods.
Excellent, Darko. And I remember this is about 10 years back, you know, when I just got into finance out of my PhD, and someone told me, hey, the equity market should react before the credit markets. And I remember trying grades or causality and not making it work. And I was like, is it a harder tool than you know, we need? And of course, you know, like you make such an important point on the SNR. I mean, even something like S&P 500 that everyone in the audience believes will go up, right? And in general, on average, gives you 8% returns over 20% wall, gives you a sharp ratio of 0.4. A t-stat of 0.4 is not enough to make a strong hypothesis in statistics, and yet that's all that we have to go to. And you mentioned such extremely important ideas. You know, the people are stuck in linear, people are stuck in stationary. And that gives me a very nice segue to go to Yevgeniy. Right? And you have looked at both deep learning and reinforcement learning. In some sense, the ideas of learning representation and the ideas of adapting to time are both prevalent in it. So can you walk us through your thinking on these topics? You know, why do you choose tools from deep learning or reinforcement learning? Are there certain limitations around them when specifically we try to apply them to finance?
Yeah, so I guess there's a few dimensions to this question. You know, I'll start from the simplest one. The simplest one is deep learning. I'll get to reinforcement learning in a second, but deep learning has proven to, you know, time and again to outperform pretty much everything else that exists out there with the right amount of effort and with the right kind of thinking. And so, you know, so that makes sense kind of at a high level strategically. What types of techniques do you expect to yield results long-term if you do it right? Well, I would say at this point, deep learning is probably at the top of the list. Now, more specifically, why do we use deep learning? So my team at BMO is not a financial team. No one on the team has financial background, like literally not a single person. They all come from tech, they all come from academia, some come from startups. And yet, you know, they're able to build models that are beneficial in a financial settings. So why is that? So typically in machine learning, even machine learning, but I would say even more so in traditional stats types of approaches that exist in finance, you need to have deep domain expertise to truly develop something that works, right? Whether it's risk models or, you know, market predictions or anything within the bank. Deep learning and the software stack that's associated with it. And I mentioned software stack because really I see deep learning as more of a pure science tool than a mathematics tool, right? Like, you know, the theory around it is quite weak. And so what deep learning allows you to do is to develop models without fully understanding the data. And this is a controversial statement because of course you want to understand the data. And yet the depth of understanding that you need to get for a specific data set or a combination of data sets is much lower to get to the same level of results than if you were to use kind of traditional stats types of methods. And so as a central AI group at a bank, you know, where our job is really to bring AI techniques to the company and bring those capabilities to the company, it's the most robust tool that's applicable across all the domains that we're involved in, right? Time series prediction, NLP, anomaly detection, all of these can be solved to a large extent through these types of techniques. I'll just get to reinforcement learning for a moment. So reinforcement learning has had success in finance, specifically around order execution, right? So there's many applications for reinforcement learning, but reinforcement learning, I would say, is the hardest, especially deep reinforcement learning, is one of the hardest areas to use correctly and to get good results, right? And so Google has had good success with that, with AlphaGo. AlphaFold and all the kind of those products that they develop. But by and large, it's very difficult. And the reason is that you need to create a simulator for reinforcement learning to work. Whatever environment you're trying to learn from, you need to be able to simulate. And you know, anyone, especially this audience, knows that simulators are hard. But nevertheless, reinforcement learning does work well in some situations, like order execution.
Makes sense. You know, you made some very important points. You know, the ability of deep learning to learn representations and to derive insight from data, the ability to change, you know, in changing regimes. And yes, the use of reinforcement learning that's really emerging in order execution, really gives us a way towards the future. And I must say this. I'm so happy that I have the three of you on a panel, because it gives me a beautiful segue from one question to another. So to you, Ed, you know, I can explore a third dimension of data analysis. You know, finance in some sense is very different from any other field of data analysis, of the fact that we get these very sudden regime changes, right? And I think of what happened last year, and you and I were discussing this. You know, the market bottoms, and when things come, when you recover from a crisis, you see certain putative stuff, right? You know, the rates go up, the curve steepens, the credit spreads tighten, the stocks go up, value breeds growth, your commodities go up, you have reflation hypothesis. That is one regime. And then you have the shocks. You have this. You can have an election shock, or you can have what's happening recently. You can have these corrections, and then you sit up wondering, saying, "Am I in a new regime? Am I in a correction?" Right? And these are not things that data can inherently answer. Right? A hidden Markov model will not be able to catch this regime change differently. And that brings me to you, Ed. You have been an expert in what we call quantamental analysis, understanding your fundamental factors and bringing them to quant. Can you talk to us a little bit about your approach? How do you apply these techniques in the context of financial trading, where data is sparse, noisy, small, and we have to bring in domain knowledge?
I think that you're right. That's the holy grail of being able to figure out, domain change, right? Or regime change, more specifically. What I've found is, and back to reinforcement learning, where I think you can do some pretty interesting stuff in that space, because it can dynamically react to current conditions in some sense, rather than, and I think I said this at this conference 2 years ago. I said, could deep learning have predicted the subprime crisis, right? Where you had 100 years of mortgage data where no one ever defaulted. And then all of a sudden within within a couple months, the default rate started going up. So deep learning in that case doesn't work, because you're kind of fitting data you already have. How do you apply, these techniques to what's happening in real time, which would apply to a regime change? It happens, I think the thing about last March was it happened incredibly fast, right? In both directions. And there are various reasons for that. But, I personally think, one way to handle it is, I think reinforcement learning, the way you structure it has a lot of possibilities, and it's, even more on the longer timeframes besides, execution. A lot of it has to do with how you structure the state space, right? You can see probably 100+ different examples that people have done in reinforcement learning on GitHub that are well done and they're fine, but everyone uses price series. Right. And if you think about that, the state space of a price series, it's just a price. If the price is 100 and then it goes to 101, then it goes to 102, then it maybe goes back to 100. What does that mean? Like, what are you learning from that? What I think is, if you can incorporate, even, just as an exercise, incorporate some, mean reversion or overbought, oversold indicators, something like that. That will get you much more than just a price series, because a price series, so if my state space is massively overbought, volatility is incredibly low and credit is falling apart with some indicator, the odds are that, things might go down, right? I mean, that's much more indicative than, say, the price was 100 than 101. So I think it's a lot of this needs a lot of experiment. It's very hard. And a lot of it, especially with reinforcement learning, which I think is able to adapt to dynamic conditions, you've really got to set the state space correctly and figure out what you're trying to do, right? And there's multiple dimensions of that. And I think it works particularly well with anything with mean reversion, right? Because if you're overbought, things can stay overbought for a long time, but generally at some point they go back to oversold, right? And that's a very simple indicator, and you can test that. But I think that's probably a better way to do that and handle the dynamic, regime change than just looking at simple price series.
Definitely agree with you. I mean, even the technical indicators, bring them into machine learning, even I have found some value, especially in the intraday scenario. And definitely with you on the need to bring in domain knowledge. And that gives me a nice segue to you, Darko. Just from what panelists are saying and what I have seen, there are still a number of quants who do stuff that look static and not as dynamic as you would want. They still might rely on a certain black box approach, and if at all an explainability comes, it comes after the modeling, right? And one thing we hear of your product is that your product fixes a lot of these issues. Can you talk to us a little bit about this? And also in this context, it'd be nice to mention that you guys really pioneered applying a lot of AutoML to time series, and now you've even transcended that. Could you talk a little bit about that as well, please?
Yeah, absolutely. So we actually pioneered automated machine learning for time series back in 2017, and we were the first to market with that product, and that was really, really good start. Now we had what's cool about automated machine learning is that you don't have to decide in advance what is the right technique you will use. You can say, well, I'm going to use deep learning, I'm going to use classical econometrics, I'm going to use classical machine learning, I'm going to have all of the algorithms. So we ended up having basically all of the world's algorithms under one roof with a very cool optimizer that was not just selecting the algorithms and the parameters, but also cleaning data, selecting features, choosing features, basically everything end to end, fully automated. And we had a very nice way of understanding what does work and what doesn't work, which deep learning architecture works and which one doesn't. So it was a wonderful start because we didn't have to make assumptions. Oh, I like deep learning, let's just use it. We were able to tell based on the data what is the right approach. And the way I imagined this was like a army of virtual data scientists all solving the problem, but without any preconception. They look at the data and decide what to apply. So it was wonderful. What we concluded though, and I think what people that have used AutoML would have concluded, including deep learning, including all of the techniques, is that these techniques overfit on financial time series data. They look wonderful in a back test. Everybody has a Sharpe ratio of 50. But when you put them in production, the Sharpe ratio becomes not so great anymore. And there's a simple, it's essentially over optimization. Now, whether you use deep learning is particularly bad for this because it has so many, moving parts that you can fit absolutely anything you want to it. And so I would say all of this falls into the curve fitting part. So from 2017 till today, we built the best product for AutoML. Great, we licensed it, everybody loved it. But we were working on causal AI that doesn't have these overfitting problems because it's able to understand the difference between association or correlation and the cause and effect relationship. What we found out is that our models became a lot simpler. So even our deep learning models became much more simple. They didn't have 1 million inputs. They maybe had 4 or 5 inputs, but they were the right inputs. They were a lot more constrained. So all of our models became simpler and started working in the real world. Now, what's really nice about causal AI that AutoML doesn't give you, causal AI starts with a full explainability before you do the fitting bit of the model. So the causal diagram describes the cause and effect relationships in your data that you learn from the data automatically, of course. And you get that causal diagram before you do the model building. So you have actually ex ante explanation as opposed to ex post. So rather than building a model and then trying to explain it, by that time you've picked up all the spurious stuff. So you're explaining, you know, and you have confounders, all sorts of bad stuff. Whereas if you explain the model before you start building it, you know, when you build it, is the same model. You don't have to explain it anymore. It's been explained before the fact. So that's really cool. And for domain experts, like Ed was alluding to, you can actually interfere with a causal diagram in a way that maybe some data that wasn't part of the initial data set, you can bring in and say, look, because I understand this market and the data didn't, you know, this variable wasn't present in the data, I can adjust it in a way that when the fitting happens, it takes into account what I believe. So you solve, you know, you solve a couple of problems. You solve explainability ex ante as opposed to ex post. You bring in the human expert and you don't overfit. And you don't have to commit to what is the right algorithm. If it ends up being, you know, a deep neural network architecture, that's fine, but it needs to be based on a causal structure which does not change after you feed the data. And so that's really exciting. And what we find that our clients now have models that work in the lab and in the real world in exactly the same way.
That's really, really exciting. You know, like what you have said will be music to everybody's ears. And as you're speaking, Darko, I was thinking of your team replacing my job as well. Because, you know, the reason I have retained my job is I've been telling people saying, look, you have techniques from 4 disciplines. You have something from statistics like Bayesian modeling. You have something from serial processing like Kalman-Filter. You have something like econometrics like Armagosh. And you have something from machine learning. And so far, a computer can't do it. And what you're telling me is a computer can do it. So that's...
Yes, we can talk offline. Hopefully, we still keep your job. We make it, you know, even more exciting. Yeah.
That is, you know, that's perfect. So human in the loop and man plus machine is always very good to hear.
That's right. That's right.
And so you know, that gives me a segue to slightly a non-analytics topic. So Yevgeniy, you have a background that spans an enormous number of super interesting topics. So I'm going to pick one here. You done some work on differential privacy, and it has implications on data democratization. Do you see the technology at a level, you know, where it can be used in practice in finance? You know, so is differential privacy at a level where it's not just in academia, you have tangible products. Are you seeing use cases of it, especially in the financial sector?
Yeah, great question. So I think it's similar to any other security product. Nobody buys security until they realize they don't have a choice, right? That's kind of the sad thing about security. So differential privacy is no different. It definitely has a role to play in finance when you're trying to enable something that wasn't possible before, right? So you mentioned data democratization. Imagine that anyone in your company could start working with something that's a proxy to the real data. It's not the actual raw data, but it has some properties. You know, Darko was talking about curve fitting. It fits a bunch of curves that you want it to fit, right? It's not the real data. It's close to it in some way. And so differential privacy allows you to do that. It allows you to create these synthetic data sets as well as synthetic models, meaning models trained where the removal of the private data happens during the training process. During the gradient descent, you actually inject noise into that process. So what it allows you to do is to create these proxies to your original data that are close enough to demonstrate the point, right? So, you know, imagine someone somewhere in your risk department has an idea they want to prove out, right? And it really empowers the more kind of junior folks in the organization, right? So it allows them to start doing work to prove a point with data that's not the original data, but it's similar to it, right? And then once you've proven your point, you can go and go through all the compliance, all the approvals, and so on. It's not the most exciting process. It's not interesting in that sense, right? You're not making money directly by doing it, but it's an enabler, and it expands the circle of people especially in a large organization that can participate in this process.
That makes sense. And it will become interesting once the regulators get in. So then then as you said, security becomes absolutely essential. So it will get
exactly.
through.
Yeah.
And it, it is fascinating. I mean, from a mathematical sense as well, it's something that's extremely fascinating, and I do see applications of it there. And and that brings me to you, Edward. I want to continue on this, on the topic of the quantamental approach. I mean, you have used fundamental factors. You have worked on clustering models, on ETF trading models. And you and I had discussed some, the use of Monte Carlo simulations of understanding some of this quantamental approaches. You and I have discussed how things have changed around elections, around the increased focus on green and infrastructure tariff. Could you talk to us a little bit? What's your advice to the quants on the call? How should they look at the current environment? And is there a quantamental framework that they can bring to bear by looking at the current market conditions?
This is a extremely interesting question. So you mentioned, regime change, earlier, and I think what you've got here, especially after last March, the amount of, say, involvement by the Fed and the ECB has really kind of stepped up to another level, even beyond what they were doing before, right? So that's definitely a regime change, right? Because that affects markets, that affects valuations. People talk about GameStop, but a lot of stuff has been doing that since March, right? I mean, it just goes straight up. So given that, now we're talking about another regime change where, a topic that I really am pretty passionate about is the ESG space, right? And that is definitely going to be a regime change, because anytime you get policy-driven markets by a government agency or, the Fed or something like that, that's going to lead to capital dislocations, which means opportunity, right? And so I think a challenge for the classic quant framework, right, is how do you handle policy-driven markets that are dictating things that are completely forward-looking, right? There is, let's just take a very big macro view here and say, okay, in 5 years, someone's going to develop a very good battery, not a lithium-based battery, but a battery that can power, big trucks, cars in the snow, these types of things. And all of a sudden, the vehicle fleet is completely electrified, right? The macro implications are, well, now you don't need the Middle East for gas. You don't need fracking anymore. And there's this big cascade of macro things, right? You can't back test for that, right? You can't back test for a lot of things going on in the world right now. If you look at the most valuable companies in the world right now, they're all basically AI-based models, except for Saudi Aramco, right? Which that's kind of a different thing. But everything else is Microsoft, Facebook, and what it shows that ML works, analytics work, that type of thing. So the question is, how do you apply this to forward-looking markets? When you really can't do a back test, how do you react to policy? The Biden administration is probably going to barrel into ESG policy requirements for 401ks and, retirement funds pretty heavily, in theory. That's what I've heard after all the stimulus bills are done and that type of thing. So this is a big focus, right? So what can you do if back testing isn't going to apply? Clearly, this is a big area for scenario analysis, Monte Carlo simulation. What works, what doesn't? What are my probabilities? What is my outlook here? Do I think someone's going to build a better battery in the next year? Is it going to be 5 years? Who's doing that? I'm not saying go out and buy, battery SPACs, but I think people need to be aware of it now. There are some big macro shifts going on here, and once the government sets a policy, any policy, you're looking at capital dislocation, and this could potentially be very big. And you're seeing it on the pension fund side. People want their portfolios adjusted for this stuff, right? I mean, it doesn't matter that a fracker has the best cash flow profile on the planet. People are going to say, I don't want anything to do with that space. So, this is ripe for quantamental analysis, especially on the NLP side, with financial statements and what people are doing. There's over 1,000 viable ESG data sets right now. The curation alone on ESG is just a massive effort. and I think people are just starting to realize that, there's a lot here, and it's very active. It's almost like revenge of discretionary, right? Everyone's going to have to become a venture capitalist almost. And it's a much different paradigm than the classic quant backtesting framework. So I think there's a lot to do on the analytics side, but I don't think it's so much going to involve backtesting. But, the forward-looking scenario analysis, Monte Carlo, the quantum mental stuff, maybe, classification, that type of thing, I think is very promising. And I'm pretty excited about it.
Makes sense. Quite a few comments come to mind, and as you're speaking, it's on the regime change thing. On the big things that are quite unprecedented. I just remember seeing the graph on the Fred website of M1, money supply in US. It went from 1 to 4 trillion, and I freaked out. And it's gone from 4 to 18. So those numbers are absurd. In 1 year, we've gone from 4 to 18. It's unbelievable. And you mentioned, yes, and the ascendance of the digital companies, the so-called digital interface, which have very low marginal cost, zero transaction cost. They have very high operational leverage. These companies doing very well. And yes, we see the challenges around the 60-40 model, the change in correlations. All of these are extremely, extremely exciting. I want to devote the remaining time of the panel to get to know, one project from each one of you. I realize each of you is involved in a spectrum of projects, which are all super interesting. So I just thought, I'll go through the panel and ask you all to pick just one project which you think, and what's it that you learned from it, and what is it that the audience can learn. And Darko, I believe you've done some very interesting work in banking, which even involves questions of going beyond why something works, and even involves things like counterfactuals. Can you tell us more about this project, please?
Absolutely. Actually, I was going to provide a different example, but maybe sure. The example that Ed mentioned, I think it's a very good one to talk about counterfactuals and interventions. I couldn't agree more with what Ed said in terms of you cannot backtest things that are about to happen. And if you try to do that, you're essentially going to overfit again, and you're going to make the wrong decisions. So you need to look beyond training data, and classical machine learning, or current state of the art, can only work with historical data by definition. Now, how do we go, how do we keep all of the good stuff from the machine learning, but also have the ability to bring data that is not in the data, so to speak, in the historical data. And so this is where causality and causal AI comes to the rescue, because it allows you to do two things. The first thing it allows you to do is to run what if intervention type of analysis. And there's two actually different type of interventions. There is an intervention that you can perform, which would be reduce, let's say, exposure to an asset. That's something you are in control of. But there's also an intervention that you're not in control of, like the ESG policy that Ed was talking about, something that the environment is imposing on you. And so if you have a cool simulation engine based on causal AI, you're able to understand the what ifs of both of this intervention, the external and the one that you can affect. Monte Carlo and the rest are like a very good starting point, but the trouble is that they're really based on normal distributions and are generated from historical data. So it really is like permuting the historical data. It doesn't really get you that far. When you have what if or interventional type of analysis based on a causal AI model, you can go beyond what's in the available data and answer these questions in a lot more meaningful way. Now, so that's the intervention part. The counterfactual part is also really exciting, because it allows you, what is counterfactual? Well, counterfactual is contrary to the fact. So something that hasn't happened. So counterfactuals are a key building block of causal AI. And what they allow you to do is to imagine, it lets machines imagine things that haven't happened yet. So kind of like the simulation with Monte Carlo, but cooler than that, because it's not manufactured from past data using normal distributions. So it allows you to answer questions like, how would my portfolio behave if the environment changed in a certain way? And you'll be able to do a forward test, I guess, like a back test, but a forward test, using data that doesn't exist in your training data, and it's quite cool. So by using counterfactuals and by using interventions and a simulation technology based on a causal AI model, I think that is the future of quant, and it's probably the only way to answer the questions that Ed was alluding to, which are really, really important, and are probably the most fundamental. And it's going to really make the difference between quants that are curve fitting and picking up basically technical patterns, mean reversion and momentum, to quants that really understand the market, are able to inject some human thinking into it, and be able to forward test those ideas in a really robust framework.
Makes sense. Just in the last sentence you mentioned this, quants who understand the market. It's so important, and indeed it's something that we have done. So I run data science for Bank of America's global markets, and we offer an AI advisory to our clients. And what we indeed do is we bring in people from market research, bring in people from quant strategy, and bring in people from technology, combine them and using it, and then we are trying all these techniques to advise. And this is extremely, extremely valuable, and it's I completely agree. And that brings me to you, Yevgeniy. I have to mention, it's just perfect timing for the panel, because you guys won 2 more awards in addition to all the accolades: the BAI Global Innovation Award, the CausaLens Annual Model Award. So I think the audience will really benefit from knowing about your award-winning cash track product.
Sure. I was actually going to talk about NLP, but I'll talk about cash track since you mentioned all these awards. So I'll say something that's not really quant related or technical. I mean, the success of this product is really a combination of 2 things. One is, the ability of the team to deliver, and I think that's kind of clear and comes across. The other part is really the drive of our digital product organization to utilize these technologies and to scale them up, right? So if you look across the industry, and it's less so in the quant space, of course, but by and large, there's a tendency for AI-driven work to kind of end at the POC stage, right? I think everyone's familiar with that. Everyone has seen those fancy POCs that go nowhere. So kind of driving initiatives end to end is key to success. And so I think what this really demonstrates is that AI actually has a massive potential to impact customers in a positive way, right? So we've built this model. It's a deep learning based model, but I wouldn't say it's something that no one else could have possibly imagined, right? It's early days for deep learning in finance, and there's kind of lots of opportunities. But the unique thing here is that this opportunity was taken all the way to production and all the way to scale with all of our online customers. And so I think that combination of kind of taking innovation and driving it all the way to like real impact is key here. Now, let me talk a bit about the the models and kind of the approach itself, right? So obviously I can't disclose exactly how it works, but if you think about the massive data sets that banks have around transactional data, around consumer behavior in their retail checking and savings, credit card accounts, there's a lot that you can do to alert clients before something adverse happens to them, right? So what CashTrack does is it monitors your accounts, and based on your spend and your normal behavior, it tries to identify a situation where you may fall short. So a situation where you're going to hit 0 and get charged an overdraft fee. And so in some cases it's unavoidable, right? Like sometimes you're going to fall short, nothing you can do about it. And there's other options, there's other products and lending kind of instruments that you can leverage for dealing with that situation. But there are many situations where you just forgot, you didn't transfer money, or you kind of didn't pay close attention to your spending, and that's especially acute in the COVID era, right? So people's financials have changed, their spending patterns have changed. There's a lot more unexpected financial events that happen to our retail client base, and so this product helps them save money, right? And it also just prevents bad things. So I'm excited about it, and I think that's kind of why the industry is excited about it.
That's really inspiring, Yevgeny. It's just, it's, as you said, so many people talk about deep learning. You guys have a massive deep learning model that's touching millions of customers. That's something that's exceptionally exciting. And that brings me to you, Ed. Ed, I must say I am a huge fan of your work. It's like so many people talk about greenwashing. Like they talk about green, but mainly greenwashing. But you've been involved. You've been an operations supervisor. You have coordinated habitat restoration. You have coordinated on birdhouse maintenance. You have recorded nesting habits. But you've done a lot on actual environment. Much more than I have ever been able to do. So, and it's not only on the actual front, you work with Erasmus University on the Sustainable Development Goals. You looked at ESG investing. So I was hoping to pick your brain on ESG investing, in general. What is the state of affairs? And, I realize we have obligations on not revealing too many details on what we do, but could you give us an overview of your thinking on this topic?
I think the state of ESG investing is, it's very exciting, right? What's going on? It's tricky. I've seen multiple kind of examples of why ESG outperformed last year. There might be some causality problems there. I think that, if someone had Tesla in their portfolio and it went way up, I'm not sure that that's kind of ESG to invest in Tesla, but, that's, that maybe not, right? I think there's going to be a ton of opportunity, like I said, in terms of capital dislocation. And like I said, we're not clear on what kind of policies the federal government is going to be implementing. Most likely there's going to be something, and it could be extensive, probably in the next couple of weeks. Again, that's going to cause capital opportunities. But, I think the big thing is, data on the ESG side. How do you use data? What is the most coherent data set, right? Everyone talks about MSCI, but there's a lot of niche stuff. People are doing a lot of cool things. There are data sets that are people using AI to build. It's all a different format too. Some people have binary flags. Some people have qualitative data. Some have, it's all over the place. There doesn't seem to be any kind of definition. So like I said, it opens up a lot of room for the quantum mental analysis stuff. And again, it's going to be a challenge, I think, for the traditional quantitative portfolio to kind of analyze this, right? I mean, is John Deere an ESG stock? I mean, if you look at the macro implication of John Deere, their robotics programs are fairly sophisticated. And if they can cut fertilizer use down 90%, that's a big deal, right? If they can cut water use down because of advanced analytics, they've done a great job with that type of thing. Yes. So there's a lot of things going on in business. Most of it is being developed very rapidly. And, it gets back to what Darko said. People are going to, I think the focus is not going to be, at least for something like this, not so much on being able to backtest the last 30 years, but how can I coherently use advanced analytics and data to figure out maybe what the macro implications are and make, the micro investments at the stock level of what's going to work going forward, given policy and frankly, pretty exciting technological advancements. So I think it's going to be tricky. I think it's exciting and you're going to have to do your work, but there's a lot going on. And I think it's going to be a pretty big opportunity for quite a few people if the effort is put in.
Makes sense. And so, a note to the audience, we will run for 5 more minutes because we started a bit late. So we'll end at 10:30. So I think we can quickly go through a couple of questions from the audience. There's a question from Phyllis Rhodes. She's asking about, have you run your models on elastic cloud resources and how complex are these resources to access? Yevgeny, would you want to take a shot at that?
Yeah, so we take a hybrid approach. I mean, by and large, our direction is the cloud, and a lot of the work that we've done is on the cloud. One thing that cloud providers offer that's kind of more complex to do on-prem, or I guess it requires a bigger investment, is GPUs. GPUs are necessary for the type of work that we do. So even if the models themselves sometimes end up running in regular kind of on-prem infrastructure, the training of the models and the research work and the development happens in the cloud. It's certainly let me put it this way: if you don't have cloud, you're gonna have a very hard time building AI solution. Yeah,
makes sense. Makes sense. Let me take up a question from David Schooley and Edward. This could be something that you could answer. So David is asking, what have you found is a good approach to speaking with traders regarding confidence in AI ML in trading?
I think it depends. And I know quite a few people in that are traders, right? I think trading is different than portfolio management, right? I think one of the interesting things is about the again, the dislocation last March was, if you go back to the previous big dislocation, which was 2008, a lot of banks struggled pretty badly. You had groups blowing up and, mortgage groups, going bankrupt and things like that. I think last March, a lot of market makers or traders at the bigger banks did very well, right? I mean, a lot of people did very well last year off of this. So I think that's kind of a change. So trading, I think, is interesting. I think there's still a lot of basically discretionary traders out there. It depends on the space. I think the more niche spaces like, leverage loans and things like that are basically discretionary. Electronic execution on the equity side, I think probably dominates. I don't think there are that many discretionary execution guys. So I think it depends what space you're in. I think something that's going to be interesting over the next couple of years is the impact of, AI, reinforcement learning, machine learning, whatever it is, on bond trading, right? Because there are various levels of liquidity in the bond markets that, it ranges anywhere from pretty liquid stuff, maybe on the treasury side, to completely illiquid stuff on the structure side, right? And I think people are making inroads into that. So I think it's a pretty wide range where if you've been a discretionary trader your whole life and it works, you're probably going to be interested in MLAI, but I mean, you're not going to change your career because of it. On the flip side, I think a lot of equity trading people, on the New York Stock Exchange and stuff like that were, completely displaced by this pretty quickly. So, I think, I think it depends on what space you're talking about. But, like I said, I think it's pretty exciting, the inroads that, AIML is making into the bond trading world. And it's, it's getting more into the illiquid stuff as we speak.
Very true. And Edward, you ended up answering, multiple questions. And another question from Alicia, exactly on less liquid markets, and I think you answered all of that. So this is extremely useful. Thank you so much, guys. Darko, Edward, and Yevgeniy. It's been an absolute pleasure. I learned so much from talking to you guys, and you guys are recognized experts in AI. You're advancing the state of art, and you're making incredible impact. And I'm sure the audience is as grateful to you as I am. So I must also thank Amina Hani for organizing this conference. Thank you, Amina. You've done an amazing job. So thank you all.
Thanks,
Thank you,
Rajesh.
everybody.
Thank you so much.